Okay, so we're going to go over the piecewise functions. Now, the one that's on the study guide, it's up there. You can't really see it right now, but you have it in front of you. So when you do piecewise functions, you have to break it up into individual functions. So this piecewise functions, there's actually four things going on. You have y is equal to x plus 10. You have y is equal to 4. Y is equal to x squared plus 1. And y is equal to the absolute value of x. You should know what all of these look like. Y equals x plus 10 is a line that has a slope of 1 and a y-intercept of 10. Y equals 4 is a horizontal line. Y equals x squared plus 1 is the x squared parabola that is shifted up 1. That's the plus 1 here. And y is equal to the absolute value of x is the absolute value function, which looks like that v, right? At 1 you're at 1, 2 at 2. At negative 1 you're at 1, and negative 2 you're at 2. So the way you go about graphing this is you could just go ahead and graph each one separately. So if I'm going to graph x plus 10, right? That's a y-intercept of 10, and it has a slope of 1, which means you go up 1 to the right 1. However, the restriction on it is x is less than negative 6. So what you could do is you could graph the line like you normally would. And then you would cut it off. So this is the normal line, but this part of the function only exists when x is less than negative 6. So we are going to erase anything that is greater than negative 6. Okay? And then that's an open dot there, and that's the first part of the function. Now, if you are having trouble with that, what you could do is at negative 6, you could just plug in negative 6 into this. Y is equal to negative 6 plus 10 is 4, and that's where your graph will start, when the y value. Now, the next thing I have is y is equal to 4, and this is between negative 6 and negative 2. So y equals 4 is a horizontal line, so I'm just going to draw a horizontal line from negative 6 to negative 2. And that horizontal line is going to be at 4. Okay? So that's the next part of the graph. Then it's going to have an open dot at negative 2. Okay, the next part of the graph is x squared plus 1, and that's going to exist from negative 2 to 2. Now, x squared is the parabola that goes through 0, 0, 1, 1, 2, 4, 3, 9, etc. Right? But if you move it up 1, the vertex is now at 0, 1, and it's going to go through 1, 2, and 2, 5. Okay? It's going to look like this. That's your parabola x squared plus 1. So if you're going to graph it here, and it's from negative 2 to 2, at negative 2 you are at 5. So you see it actually does not connect. And then so what happens is your parabola looks like that. So that's part of your piecewise function. That little parabola. It only goes from negative 2 to 2. Closed dot here, and here you'll have an open dot at 2, 5. And then after that, at 2, you'll be at the absolute value of x, which means at 2, you're going to be at 2, because if I plug 2 in here, y is equal to 2, and it's going to be a closed dot, and it's going to form, and that is your piecewise function. Okay? You take each little part. The way to do this is just divide your piecewise function into its little parts and graph each one separately. When you graph them, you're going to use the interval to help you determine where to cut off your graph. Now, if that's a little confusing for you, what you could do is you could also just take these as your endpoints, right? And plug the endpoints in to find the y values, but you still have to know what the graph looks like to fill in the rest of the graph. Okay? Let me actually do one more piecewise function. So I'm going to erase this and give you one more example. I'll do something a little more simpler this time. Okay. I am going to do y is equal to 2 minus x if negative 3 is less than or equal to x is less than 1. And it's square root x if x is greater than or equal to 1. Okay. So when you do this, you have two separate functions here. You have y is equal to 2 minus x. Remember, 2 minus x is really negative x plus 2. So it's a line that has a y-intercept of 2 and a slope of negative 1. And the second function is y is equal to the square root of x. So if I use that as my restriction, negative x plus 2 has a y-intercept at 2. And you go down 1 to the right 1, down 1 to the right 1. And that's your line. But you only need the line from negative 3 to 1. So at negative 3, you're going to get cut off. Okay. And it's going to be a closed dot here. And it's going to go to 1. And at 1, your y value here is 2 minus 1. It's 1. So 1, 1 is the endpoint. And it's an open dot at 1, 1. And then now, the second part is the square root of x. Remember, the square root of x is the function that looks like this. That goes through 0, 0, 1, 1, 4, 2, so on and so on. So the graph will kind of look like this. But we only need it if x is greater than or equal to 1. So we erase this little part that goes to 0. And we see that it connects to the previous part. And that is your graph. That is your piecewise function graph. So whenever you do piecewise, you do each part separately. And then you graph them based on the interval. Okay. Now, I'm going to go ahead and do one exponential and one logarithm, just so that you have practice with it. I'm not going to do the one that's in your study guide. I'm going to do another one, and you could just apply it to the study guide one, since the answers are there. Okay, let's say I want to graph y is equal to 2 to the negative x minus 3. Now I know this is an exponential function because the variable's in the exponent. So what I'm going to do is I know all of my exponential functions. Remember, just think of 2 to the x. I know 2 to the x because that's my base. We'll go through negative 1, 1/2, 0, 1, and 1, 2. So whatever your base is, it's always going to go through negative 1, 1 over your base, 0, 1, 1 your base. So the one in the study guide, your base is e to the x. So it would go through negative 1, 1 over e, 0, 1, 1, e. If it was 3 to the x, negative 1, 1 over 3, 0, 1, 1, 3. All right? So if this is my exponential function, these are the 3 points that I'm going to transform. Now, if I transform them, if I look at my function here, the x is being negative, which means I reflect it across the y-axis, and then I go down 3. So if I reflect across the y-axis, then my x values change. So this is the reflect x-axis. So this becomes 1, 1/2, 0, 1, negative 1, 2. And then I go down 3. And then so this is 1, negative 2.5, 0, negative 2, and negative 1, negative 1. Okay, hopefully I did all that right. And then now I could go ahead and graph my exponential. So I know my regular exponential goes like this. So what we're going to do is I know that it has to get reflected and it has to move down. So I'm going to use those points to kind of help me graph this. So at 1, you're at negative 2.5. At 0, you're at negative 2. And at negative 1, you're at negative 1. Okay? So if this is your original graph, it gets reflected across the x-axis. So it's going to be turned like this, and you're going to move it down 3. So your final graph, first let's talk about the asymptote. The original asymptote is y equals 0. So your new asymptote will be at y is equal to negative 3. And then your graph will just go ahead and look like that. Okay, now let me do a logarithm. So let's say I had to graph y is equal to log base, no, y is equal to log x plus 1. Let's make this a 2. 2 log of x plus 1. Now, I know my logarithm. This is what my original logarithm graph looks like. So you should know what an original logarithm graph looks like and what a regular exponential graph looks like. So, or maybe you can't see that. I don't know. So, this logarithm has no base here, so that means it's a base 10. So remember, the way I have you think about this is an exponential with base 10. If the exponential base 10, I know it goes through negative 1, 1, 10. It goes through 0, 1. And then it goes through 1, 10. So what that means is that I'm going to reverse these for the logarithm. The logarithm goes through 1/10, negative 1, 1, 0, and 10, 1. So after I get those points, there's a couple things happening. It's a vertical stretch of 2, and then I move to the left 1. So the vertical stretch of 2 means this is 1/10 negative 2. This is 1, 0. And then this is 10, 2. And then I'm going to move to the left 1. So now this becomes negative 9/10, negative 2, 0, 0, and 9, 2. So when I graph this, first of all, since there is a horizontal shift, then that means my asymptote here, my vertical asymptote will be moved to the left 1. Okay? So let's say that's at negative 1. Then I know I go through the points negative 9/10, negative 2, 0, 0, and 9, 2. And so your logarithm graph looks like that. And so your domain here is x is greater than negative 1. The range is all real numbers. And then your vertical asymptote is x is equal to negative 1. So remember, your logarithm will always have a vertical asymptote. The exponentials will always have a horizontal asymptote. Okay, I'm going to do one rational function. So let's go ahead and graph let me find one. Okay. Okay, let's say I want to graph x squared minus 2x minus 15 over x squared plus 6x plus 9. Okay, a couple things from this. So x squared minus, if you can't see because of the glare, x squared minus 2x minus 15 over x squared plus 6x plus 9. The y-intercept is just negative 15 over 9, which is negative 5/3. The x-intercept, remember we just set the top equal to 0. So 0 is equal to or actually, what I'm going to do is I'm going to factor this. I forgot to do that as the first step. When I factor this, this is x minus 5, x plus 3, all over x plus 3, x plus 3. And these cancel. So remember, this is the... Okay, that's fine. Now the x-intercept is going to be 0 is equal to x minus 5, x plus 3. Because we're setting 0 equal to the numerator, and that's the numerator. So I have x-intercepts at 5 and negative 3. Now I have a vertical asymptote at x is equal to negative 3 from here. And my horizontal asymptote is just going to be the coefficient of this, but since they're the same degree, so it's 1 over 1, y is equal to 1. Now we have to have the horizontal asymptote make this entire function equal to 1. So 1 is equal to x squared minus 2x minus 15 over x squared plus 6x plus 9. I cross multiply, or I multiply by this on both sides. X squared plus 6x plus 9 is equal to x squared minus 2x minus 15. The x squares canceled. And I'm left with 8x is equal to 6. Divide both sides by 8. And I know I'm going to intersect my horizontal asymptote at 3/4. Okay, so now we have everything we need to graph this. So I have a vertical asymptote at -3. I have a horizontal asymptote at 1. I know I have a y-intercept at -5/3, around here. I have an x-intercept at 5. And I have oh, okay. I made a mistake with the horizontal asymptote here. I wasn't supposed to use the original for the horizontal asymptote. If you're able to cross something out, you actually are supposed to, and I forgot about this, use your simplified version. So we're going to x that out, and we're going to do 1 is equal to x minus 5 over x plus 3. If I cross multiply here, I get 3 is equal to -5, and so I don't cross the horizontal asymptote. Okay. So now, what I'm going to do is I'm going to find test points. If I choose something, if I pick something like 1, I can put it into the simplified version. So r of 1 is equal to -4/4, which is -1. So good, at 1 you're at -1. So I kind of could see my y-intercept there, my x-intercept is there. So I know my graph is going to go like this here. And then let's just check something to the left of the asymptote. Let's check -4. If I plug that in, I get -9 over -1, which is 9. And so at -4, you're at 9, which is what I want to see so that my graph looks like that.